Hello, pre-calculus. Hope you're all having a fantastic day today. Today we're going to be talking about our next unit, which involves a mathematical concept called a logarithm. And a logarithm is log base b of m. We call this b down here is your base. It's the little number between your log and the bigger number. And a logarithm is defined as an exponent to which b must be raised to get m. So in other words, you're looking at what exponent does b have to be raised to make it m. It's a relatively simple concept, but it is a bit different, so it takes a little bit of getting used to, just like all of our other stuff. Let's get down here and talk about the definitions for a little bit. Logarithm, log base b of x equals y, if and only if x equals b to the y. Remember that we're saying b raised to what power gives you x? B raised to the power of y gives you x. And there's a couple of things that have to happen here. You cannot have a base that is 0 or smaller than 0. It cannot be 1, because 1 to any power is 1. And x also cannot be greater or cannot be any less than 0. So this has to be bigger than 0. B has to be bigger than 0, but not 1. Then you have the natural log, which is your log where b is 10, where your base is always just going to be 10. We call that the natural log. The natural log of x equals y, if and only if x equals e to the y. So e is involved a lot and involved heavily with natural logs. And then you've got I'm sorry, I said that backwards. The natural log is not base 10. Log is base 10. If you don't have a b, you just assume that your base is 10. I'm sorry, I said that completely backwards. The natural log is when you have a base of e. I'm sorry, I should have said that correctly, but the natural log is when you have a base of e. And if you don't write the base, then it's assumed it's 10. So there's a lot easier to do once you actually crack into them. So log base 4 of 16 equals 2. Write it in exponential form. That means that 4 squared is 16. Kind of in a circle here. 4 squared is 16. Excuse me. B to the 5 is 7. E to the 3 equals C. So if you follow that kind of circular pattern, it's pretty simple to write. On the next one here, remember that what we're looking at is we're trying to say this base to this exponent gives you C, right? Back up here, b to the y, so b is your base. In this case, we have the log of 2 raised to the power of -3. Now the power of -3 would really make that 1/3, right? 1 over 3, because you can't have a negative exponent either. Whoa, I'm sorry, negative. I'm all over the board and I apologize. Log base 2 of 1/8 equals -3. I'm so sorry about that. Same thing here. Log base of 10 is just log. We don't have to write a base here. Of 1 equals 0. So again, it follows that circular pattern. 2 1/8 gives you -3. 10 to the 1 gives you 0. E to the 12 gives you A. Now, this one is a little bit different because with E, remember, E is your base, right? So we're doing E as a base. And anytime you have a log with a base of E, it's the natural log. So it's the natural log of 12 equals A. So a little bit different. It takes some getting used to. These we're going to do with a calculator. And I'm only going to do a few of them, and then you can go back and you can do them yourself. I'm not going to make you stand here and watch while I do them. But I do want to pick a few of these out. Log base 3 of 81. The way that you would go about typing this in your calculator, we have to use a change of base formula, which we'll cover on the next page. So for right now, if you would turn over, it says since calculators only have base 10, which is the common, and base e, which is the natural, what they're talking about here is if I pick up my calculator, I've got log and natural log right here, log and natural log. Well, if you just type log, there's no option to put a base, so they automatically assume it's base 10. If you hit natural log, there's no base, so they just assume it's base e. All right, so since you can only have base 10, which is common, base e, which is natural, the change of base formula has to be used. And it's really simple. It's log of the big number divided by log of the little number. Log of the big number divided by log of the little number. And because of how it works, you can also break this up into natural logs as well. So that's how I'm going to enter in some of these stuff over here. And I'd like you to follow along with me if you can, if you have your calculator with you. The first one is log 81 of 3. Log 81 of 3, or log 81 base 3 rather. So what I'm going to do is do log of 81 divided by log 3. And it's that simple. And it's 4. Remember that what this is saying is that 3 to the 4th power gives you 81, which is true, by the way. Oh, I'm sorry, it says without a calculator. I'm telling you, I'm so off on this. Without a calculator. Good grief. Okay, so I don't know what the base is here. Or I don't know what the answer is, rather, so I know that it's 8 to some exponent has to give you 2. Well, I know that that's 1/3 because the cube root of 8 is 2. Right? Over here, I am saying that, first let me rewrite this as the natural log of e to the -4 equals x. You know natural logs and e's cancel out, so it's -4 equals x. So that whole thing equals -4. And anywho, 5 to what power gives you 1? 5 to what power gives you 1? Well, that's 0. 5 to what power gives you 5 to the 8ths? Well, that's easy. That's 8. So just rewriting it here, 9 to what power gives you 1/3? 9 to what power, 9 to what power gives you 1/3? Well, I know it's going to have to be negative, and I know I'm going to have to square root it to get to 3, so it's a negative square root, power of -1/2. 4 to what power gives you a -4? 4 to what power gives you a -4? Well, there isn't one. Sorry, I keep writing a 0 for a placeholder. 4 to what power gives you -4? There's no power that gives you a negative number there. It just can't happen. Rewriting this, we've got log 10 to the 1/2. And since I don't have a base, I assume it's 10. 10 to what power gives you 10 to the 1/2? 10 to what power gives you 10 to the 1/2? Well, that's the 1/2 power. And I'm sorry, I should have been doing this without a calculator the whole time, which obviously is pretty easy to do. You're just looking at that circle. 5 to what power gives you 1? 10 to what power gives you 10 to the 1/2? On and on and on. Well, since we've already gone over how to do this with the calculator and change a base formula, approximations. All right. When it comes to approximations, stuff like this, log base 2 of 50, this question here, in order to come up with that, used to be what they would do is they would say that log base 2 of 50 is somewhere between 5 and 6 because 2 to the 5th power is 32 and 2 to the 6th power is 64. So it's somewhere between 5 and 6 because 2 to the 5th is 32 and 2 to the 6th is 64. So your answer is going to be somewhere in between those two numbers, right? And they used to have to just estimate. Well, we can do it with our calculator here, and it'll actually tell us. So it's going to be log of 50 divided by log of 2. And I can grab my calculator here. Log of 50 divided by log of 2. Making sure you close your parentheses there. 5.64. So it is in between 5 and 6. 3 decimal places, 5.644. Log 3 to 20. What 3 to what power gives you 20? Well, I know it's going to be somewhere in between 3 squared is 9 and 3 cubed is 27. 3 squared is 9. 3 cubed is 27. So it's going to be somewhere between 2 and 3. So let me grab my calculator here real quick. Log 20 divided by log 3. And that is going to be about 2.727. All right. Skip this business here. Log base 64 of 1/4 is log of 1/4 divided by log of 64. Let me clear that out. Log of 1/4 divided by log of 64. Negative 1/3. Technology is amazing. So change of base. And that's actually it. So change of base, we can do it with calculator, without calculator. We'll do some more when we get into class, get a little bit more comfortable with them, just as kind of an introduction of what logarithms are. Hope you have a great day.